Okay, so guys, first of all, we'll start with the fundamentals, right? So the very basics we'll discuss the packet flow of the router, right? And the routing decision, the routing protocol selections in the same part that we have in the routing decision, right? And about the network topology fundamentals, like what is unicast, broadcast, how these things works. Okay, what we have in these topologies, right? And then finally, we'll move to the remote site connectivity kind of thing, right? So I'll just start with these things. Okay, the routing decision and the properties of those things. Okay, so guys, do you have idea like if we talk about the routing decision, let's suppose we have two routers. Okay, I'll just draw design. One more router here we have like this. They are connected via like this. Okay, and from here we are getting a packet 1.1.1.1.1. Same here, we have a same subnet 1.1.1.1.1, and this router R1 is getting the same subnet from both routers. It means in the routing table, it is maintaining something like 1.1.1.1.1. Not yet, okay, not yet in the routing table. 1.1.1.1.1, and this is from, we can say R2, and this we are getting from R3. So guys, any idea like what mechanism it will be taking in the background to choose the best path? Any idea?
Administrative distance, lower admin distance.
Yeah, before that, like longest prefix.
Longest prefix. Okay. What is the very first thing, Gursimran?
Very first thing is like a longest prefix, but in this case, longer prefix both are same.
Okay, how we can decide longest prefix?
With the subnet mask.
Yeah, exactly. So what I have done here, only the IP address, right? Not the subnet mask, correct? But yes, if I put the mask 255.255.255.255, and if I'll say here, this is 255.255.255.255. Now we can say the subnet mask, or we can say the length is same, right? Because without getting the subnet mask, we cannot decide what is the length or what is the prefix length of that address has, right?
Yep.
Okay. Any doubt till this point?
No, I'm good.
Okay, cool. Next thing. Okay, I'll come to this point again, but now we should know whenever, let's suppose this router is maintaining some thing, or let's suppose this is the best path in the routing table, right? And whenever any user comes here on this interface, right? And that will be sending the packet out from this interface to this interface. So somehow the device is doing a switching part, right? Or wrong? Any idea what kind of routing I'm talking about here? Oh, sorry, switching. Whenever any of the user, let's suppose R1 is maintaining this route as the best path in the routing table, right? So whenever that user or any other user will try to communicate to 1.1.1.1.1, right? R1 will get the packet definitely and will send the packet out from this interface. So what mechanism it has done in the background here to find the best path, or we can say to find the best interface? Any idea about that part? Anything? Anything? Okay.
Just guessing like highest interface number? Or...
No, basically what we have switching mechanism, basically like what will happen in the background, or what the router will be doing with the packet, how it will decapsulate, how it will like encapsulate the packet, right? So we have three types of switching mechanism on a router also. Okay, the very first one we have is packet switching. Okay, the second one we have is fast switching, right? And then finally, the one we have is Ceph, Cisco Express Forwarding. I'm sure like you have heard about the Ceph, right? Right, guys?
No, I don't want to go there. Sorry.
Okay, no worries. So we will discuss these three things, right? So these are basically at the point. So I'll just draw a diagram. Okay, so just to make you more comfortable in this product, in this feature. So this is the very base thing on the router. Whenever it will get a packet, what happens in the background, how many things working in the background, and finally what will happen through which it will find the best interface on the routing table. So let's suppose here we have user A. User A is having IP address 10.0.0.1. Okay. And here we have user B, and that has 20.0.0.0.1. This is your router 1. Okay. Every router has two things. What? One is RP, that is route processor. One is SE, switch engine, right?
Mm-hmm.
One we have is route processor. Okay. And the other one we have is switch engine. Now, these two things will be working in the background to send your packet, or we can say to pick your packet from this interface, and we'll be sending the packet out to this interface. Okay, we'll see what happens here in the background. So this is F0 by 0. And this router is maintaining the information 20.0.0.1 is directly connected to F0 by 0, something like that, right? So that routing part we'll discuss once we start the main routing or those decisions, right? But right now we are assuming this router has that information in the routing table 20.0.0.1 is the best reachable via F0 by 0, or that is the table in the that table is maintaining this kind of information only. Okay, that we are talking about. Now, next thing. So first of all, I'll discuss what is packet switching. Okay. Then we'll discuss what benefits we have in the fast switching, and then we'll discuss what more benefits we have in the Ceph switching. So guys, do you have any idea about these switching methods? Tanak, any idea, brother?
No, Ceph is like belong to Cat OS from Cisco, like the latest one, like which is follow with the 9300 also.
Okay. I'll start. No worries. I'll just start one by one. First of all, do you know what is the use of this RP? What is the use of the switch engine?
So RP is like a, can say control plane, and the switching is like a data plane, when something like that, or
Yeah, kind of. I'll explain. So whenever we talk about the route processor, right? So this process, or we can say this route processor, is responsible to handle control plane. Right now, the thing is, what is control plane now? Right? We'll discuss these things also. One we have is switch engine. Like the responsibility to handle the control plane. It means that is trying to build the routing table, right? Because control plane, it means I'm getting some information from the next router, right? And I'm trying to assume, analyze that packet, and will try to put some information from that packet to my routing table, right? So that kind of information RP does, right, in the background. Switch engine, this is basically will take care of forwarding plane and will maintain R table also, which MAC will be used to reach a specific destination. Okay. I hope this part is clear. What RP is doing in the background, what switch engine is doing in the background, right?
yeah.
Okay.
I don't want to mix up, but it's a kind of like in Juniper they have two separate platforms, right? Like routing engine and forwarding engine. So, but Cisco it combined, right, in iOS. So, but
this is how these things work.
Okay.
Guys, just give me 2 minutes. Huh? Just 2 minutes.
Hello, Neeraj. I lost you.
He has put on hold for 2 minutes.
Okay.
Okay, I'm back. Yeah. So, good Simran, like this point is clear. What RP is doing in the background, what switch engine is doing in the background.
Yes.
Okay, very cool. Next thing, I'll just talk about the packet switching. Okay. So, same diagram I will pick. So let's assume this user A want to send some packets. Let's suppose we are doing a ping communication, right? And in the ping communication, this user want to send few packets, or we can say, let's suppose 1,000 packets to switch B, right? And this interface, let's suppose we can count as F0 by 1. The MAC address here we have is B, the MAC address A, the MAC address C, the MAC address D. So guys, right now I will not talk about how this user will get to know what MAC address it has to use, right? I will just create my packet with the MAC addresses and will flow the packet, okay? So I'm sure like the ARP request, ARP reply, that mechanism is clear to all of you, right?
Yes.
How that works? Okay, cool. Next thing. So user A will be creating a packet. So it will be maintaining, like it will have ICMP first of all. It will have 10.0.0.1 as source IP address, 20.0.0.1 as a destination IP address. The source MAC will be A, and this time the destination MAC will be B, right? Because these layer 2 information changes on the every hop, right or wrong?
I'm sorry, can you repeat? I didn't hear.
Yeah, sure. So basically what is happening here, user A just want to do a communication to user B, okay? And the MAC address here we have is A, B, C, and D. Now, next thing, user A want to send 1,000 packets to user B, okay? And this is the very first packet that user A is trying to send. So, very first packet we talk about, or those 1,000 packets, all the packets will be like this, correct? The IP address is source and destination IP address, source and destination MAC address, and it will send the packet out to the B, right or wrong?
Yeah.
Yes.
Right.
Okay. Now, and as we know, like these MAC addresses, the layer information will be changed at every hop, right? Once the packet will be here. So the source and destination MAC will be C and D, but they cannot change the IP addresses at that time, right?
Right.
Cool. Next thing. So user A will send the very first packet to the user B, and now what happens in the background that we will note down. The very first thing, switch engine will get the packet, or we can say switch engine will receive the packet and will process it. Second thing, what processing it will be doing in the background? The very first thing, switch engine will remove layer 2 data. So basically it is checking, okay, can I receive it or not? Processing, it means yes, that is in the background, it is checking the destination MAC is my interface address or not. So yes, that will find B is here, so I can receive it. After receiving, what I have to do here, I have to remove the layer 2 information. So switch engine will remove layer 2 data, or we talk about this layer 2 header. Okay, layer 2 header. So it will remove the layer 2 header. Fine. The third thing, now what it has, switch engine has a complete IP header, or we can say IP data with ICMP and IP header, right? Because now that is having, the switch engine is having only these two information. Now what it will be doing? Switch engine knows if any doubt, guys?
No, I'm good.
Okay. So switch engine will say, now I have a data of the layer 3, right? So I should hand over the data to RP, because RP is having the main information, the L3 information, and that can give me the correct interface to send the packet out. So what will happen here? Switch engine will hand over the packet to route processor. Finally, route processor will check destination in routing table. So the RP will check destination in the routing table. Sixth, RP will do a recursive lookup if required. Find the destination best interface. Okay. Now guys, just tell me, do you know what is the meaning of this word, recursive lookup?
Finding a direct connected interface from where to reach to the destination.
Okay, whenever the device will be doing one more lookup or two or more lookups to find a destination interface. Let's suppose we have something, we have some address, 1.1.1.1 is reachable via 2.2.2.2. One more route I have, how that 2 is reachable, that is via 3. How 3 is reachable, that is via 4. And how 4 is reachable, that is via F0 by 0. It means to reach 1.1.1.1, exactly what we have, F0 by 0. But to find the real best path, it will be doing the recursive lookup. It means one by one, it will be start checking the 1, 2, 3, 4, 5, 6, 7. So like this, it is doing a recursive lookup. Okay. So I'll talk about, you can just note down this point. Okay, I'll talk about this later. No worries. So RP will do a recursive lookup if required to find the best exit interface for the destination. Finally, RP will find the best interface to send the packet out. And now what RP will be doing? RP has the F0 by 0. So it is saying whenever anyone want to communicate to 20001, you can use F0 by 0 as a best interface. So now RP will hand over the information of destination interface to switch engine. Now finally, again, the switch engine again has the packet, right? Ninth, switch engine will check what new MAC addresses I can put. Now again, I'm not talking about the MAC address or those ARP request reply, because here whenever it will get the packet here, and if the router don't know the MAC address of the 20001, so before going to the next step, it will try to get the MAC address, or we can say it will do the operation of ARP request, ARP reply. It will get the reply, and then it will do this process. Okay. So that's why I'm saying the ARP request reply mechanism is already done there in this diagram. We are just talking about the packet flow, okay, in between a router. Switch engine will check the new MAC address entry, what I can put here in the packet. Okay. Then switch engine will add new layer 2 information. So that is C as a source address and D as a destination address, the destination MAC address, right? And 11, switch engine will push the packet out to F0. Or we say, if I'll talk about the technical term, it will put the packet on output. Okay. Finally, it will put the packet on the output queues. So guys, I'm sure you are aware about the output queues, input queues, right?
Yeah.
Great. So finally, it will send the packet out here. So this mechanism, or we can say these 11 steps, will be done by the RP and switch engine for all those 1,000 packets. It means, let's suppose this device is getting 1 lakh packets, right, at that time. So RP and switch engine has to maintain those 1 lakh packets. Okay. So what issues here we have? Can you tell me now? Okay, first of all, tell me one thing. Do you have any doubt in these process? Anything, any point, if you feel like we need to discuss again, so I can explain again that point. So just go through with these 11 steps, right? And just tell me any doubt till this point.
Yeah, Neeraj, like from the 5 to 6, like already it's like straightforward, right? Like the routing table has a direct interface. The distance would be 0, and it know the exit interface already. Why look for a recursive lookup again?
I have mentioned if required, because we might have a different
Okay.
case, right? That can have a static routes more than 1, more than 2. So that is why
Okay.
if required, that will do this part. Otherwise, it will just have that information, right?
Okay, got it.
Just go through with all the steps one by one. Good, Simran, you also.
Yeah. Okay. Yeah, I'm good.
Okay. So now, do you see any issue in this in these process? What we have here, that is not good for a router.
I mean, it's like it making a lot of process, right? Every time for every request.
Exactly, because if we see switch engine has that task, right? So switch engine is the responsible person, like to do this task, right? But what is happening here? The RP that has a responsibility to maintain the control plane. But right now, what is happening here? Just because of this process that is maintaining every single forwarding plane data, right? So if we get some extra data, or let's suppose somehow if we get n numbers of data, RP down due to high CPU utilization, right? Correct. Because right now RP is handling two things. One is the control plane and one is forwarding plane also, right? And if it, let's suppose it start getting multiple packets like one by one, and in between it, if let's suppose it gets some packet like OSPF packet, EIGR packet, so at that time RP might put that packet on hold, right? Because it will be busy in the packets and the forwarding plane data to process it, right? So at that time there are chances like it will put those packets on hold, and we can have some issues over there on the device, right?
Yeah, maybe latency.
Yeah, definitely. Or maybe it will just process first of all those layer 3 data, because whenever we talk about the control plane and forwarding plane, right? They both have a different priority number, the toss bits. During the toss bits. So whenever any router gets a control plane packet and a forwarding plane packet, the router first of all processes the control plane. It will put all the packets forwarding plane on hold at that time if that is getting too much control plane data. Okay. there is a part of collateral services, right? What happens in the background, what happens, like which bit it use in the background. But yes, whenever an router gets a packet of the control plane and forwarding plane, it prefers the control plane just because of those toss bits. Okay. So this happens in the very first packet. So any doubt at this point?
No.
Okay. Somewhere this is called as process switching also. Okay. Now I'll talk about what is fast switching. So nowadays, no one use these process switching, the packet switching, right? Now, if we talk about the fast switching and the Ceph, so all the other vendor device use the fast switching, and the Cisco use Cisco express forwarding mechanism. Okay, so I'll come to this point. What is Ceph? Before that, we'll talk about what is the fast switching. Okay, so I'll just pick this diagram. Okay, one more thing here. This complete process, or a process where switch engine encapsulate layer 2 information and add new, or we can say and encapsulate new layer 2 information is called as packet rewrite. Okay, so when someone asks what is packet rewrite, so this is the mechanism, is the packet read. Okay, so whenever the switch engine removes the layer 2 and add a new layer 2 write, so that mechanism is the packet rewrite. Now, okay, so again, I'll start with the very first packet. Let's suppose switch, this user A is sending the very first packet to the user B, right? And the same MAC address here, we have A, B, C, and finally last here we have D. Okay, now next thing. So we can say these steps are same. Okay, these steps are same. Now I'll put some new steps here. Switch engine will put that entry in the cache for future use. Okay, this cache is basically flow based. Okay. Now, so whenever the switch engine will get this information from the RP, like if you want to communicate with 20001, use F0x0 interface, right? So the device, the switch engine will put that entry in the cache entry, right, for the future use. Now, 10, what it will do, again the same thing, switch engine will find the best MAC address to send the packet on F0x0, and finally switch engine will encapsulate new layer 2 information and will push the packet to output queues. Okay. Now, this was the process for the very first packet. Now, what happens for the second or third packet or those remaining 999 packets? So that's a different part now. The very first thing. Now, this is the steps for remaining packets, right? These 11 steps we had for the very first packet, but now the remaining 999 packets, what happens with those packets? The very first thing is switch engine will receive the packet and will process again, like it will check the MAC address and I can get the packet or not and will receive it. Second thing, switch engine will remove layer 2 data. That means it will decapsulate layer 2 information. Third, switch engine will check the cache entry and will find the best exit interface to send the packet out. Finally, switch engine will add new, or we can say will encapsulate new layer 2 information and will push the packet to output queues. Okay. Now this happens for the remaining packets. Now it means we have something better in fast switching, right? Correct. So this happens in the fast switching. So just go through with the steps, right? And if you feel any doubt, we can discuss again.
Like kind of like first when the router receives the first packet, so it will go out through that 11 processes, right? And it put the entries into the ARP table, right?
Yeah. Yeah, if you talk about the ARP request supply, right? So that's a mechanism, yes, that will happen in the background, definitely. Okay.
Neeraj, but what happens if the interface, I change the interface to different? So it will start again because it's already have a cache information, right? First, it will try with the existing entry, and once it failed, it will start from start.
Exactly. If let's suppose the device did not find the entry, the cache entry, it will do this complete process.
Okay, got it.
But here in this case, let's suppose if the router gets 1 lakh different flows. So at that time, the RP has to maintain at least a single packet of the flow there, right? The data plane packet, correct?
Yeah.
Cool. Next thing, if this is good, then we can move to the Ceph, right? All good till this point?
So if we face any malfunctioning, like what do you say, like a lot of flooding, if we want to clear this cache, can we clear with the command?
No, that is flow based. Let's suppose you are doing a ping communication, right? You are sending 1000 packets. So at that time only the cache will be there. Once your flow is finished, right? Your 1000 packets are 0 now, right? So that cache will automatically get removed. Okay.
Oh, okay.
That's why I have written here. This cache is flow based cache.
Okay.
Once the flow is over, the cache will be removed from the device.
Oh, okay. So every flow it will run the entire process. Okay, got it. Yeah. Yeah, then more reliable. Yeah.
Good, Simran, like any doubt at this point? Anything?
I'm good. Understand.
Okay, perfect. Hi, Praveen. Any doubt till this point? These things?
No, sir. No.
Okay, great. Okay, finally, let us discuss the Ceph mechanism. Cisco Express forwarding. Okay. Now, as I told you, like the device will be having RP, the device will be having switch engine, right? Now the device will be maintaining one more table, that is Ceph table, right? So what happens in the background basically, as we have discussed, we have RP, we have switch engine, right? So whenever RP will try to handle the control plane and will find the information, right? We'll have the information. What RP will be doing? It will do all the recursive lookup. So RP will share at the same time RP. Let's suppose RP is learning some new things, learning a packet with address 1.1.1.1 on slash 32. But that is reachable by any other interfaces, right? That is fine. So what RP will be doing, RP will first maintain that prefix in routing table. Then what it will do, RP will do all recursive lookup and will share the information of prefix and best exit interface to Ceph. Okay. So parallelly, it will be doing the same task. It means whenever the RP will be getting the packet or any control plane, right? Getting the packet, right? Any control plane, right? So at that time, it will do all the recursive lookup if possible, right? And will hand over that entry to the Ceph table. It means parallelly, the Ceph table will be refreshed every time whenever the RP will get any information or any control plane, right? So Ceph table will be having all the latest entry. After doing all the recursive lookup, RP will share the information to the Ceph table. So what happens in the background now? If we talk about the process for all the packets, right? The very first thing, the same thing, switch engine will receive the packet and will process it. Second, switch engine will decapsulate layer 2 data. Third, switch engine will check Ceph table and definitely it will find the entries. Fourth, switch engine will encapsulate new layer 2 headers. Finally, switch engine will push the packet out to output. That's it. And every time it will be doing these tasks. It means now RP never handle any single packet. RP is not responsible to handle any single packet of the flow, right? So in this case, RP is just responsible to handle the control plane. We have the Ceph table. So, switch engine will check the Ceph table. Do we have any entry over there or not? And it will pick the entry, pick the information, and will send the packet out to the next interface. So this is how the Ceph is working in the background. Okay. So look here. When we have the Ceph, there are only 4 to 5 steps. Any doubt till this point? Anything?
Got it.
All go till this point. Okay, great. So this was the process where we can have the packet switching, fast switching, and the Ceph, Cisco Express forwarding. And this is how whenever a router gets a packet, it will switch a packet from a single interface to another interface. Okay. Now we can move to the routing decision. So as we have discussed, like in the starting, the very first thing it will be checking, that is longest match. Absolutely right. The very first thing it will be checking, or a router will be checking longest prefix match. The second thing, so after longest prefix match, let's suppose both are same. It will be checking AD value, or we can say lowest AD value. Third, after let's suppose the AD value is tie, right? At that time, it will be checking lowest metric value. Now it depends. Let's suppose we are using a RIP protocol, right? So it will check lowest hop count at that time. Lowest hop count in RIP. Right. Lowest metric in EIGRP and lowest cost in OSPF, right? So that AD can be typed for the RIP, AD can be typed for the EIGRP, AD can be typed for the OSPF also. And at that time, if that is a EIGRP, it will be checking the lowest metric of all the routes, right? If that is OSPF, right, it will be checking the cost at that time. If that is RIP protocol, it will be checking the hop count, because hop count is a metric value in the RIP protocol, right? And even after that, if let's suppose the hop counts are same, lowest metric is same, lowest cost is also same in the OSPF, what it will do in the last one? Any idea? Anything?
No idea about that.
It will do load balancing.
Exactly. Now it will perform the load balancing. Correct.
Yeah.
Okay. Now we have two things. What is load balancing and what is load sharing? Any idea? Because if we clearly know what is load balancing, right, then we can have a clear view of this complete routing decision, right? So I'm sure this is clear. This is clear. We'll talk about these again. This is most clear, right? What is load balancing? Any idea?
I mean, a lot of technologies, right? I mean, based on algorithm, round robin is sharing, forwarding the packet.
I'll just take a simple example, right? Suppose we have a router that is connected to two more routers, and that is getting a subnet from this router, a subnet from this router, and here we have a LAN user that is trying to communicate to a destination 1.1.1.1.1, and this device is learning, that is maintaining the information 1.1.1 is best path via R1, and also in the routing table it has R2. So it will do a load balancing, right? And let's suppose this user, a user that is trying to communicate to 1.1.1.1 is sending 50 packets. Okay, so what happens with these 50 packets? This is your R1. Okay, this is your R2. Now just tell me how this device, this router, will be doing the load balancing. What happens in the background?
Once they found the two exit interface and the cost and everything same, like first one will go to R1, second one will go to R2, something like based on algorithm.
Okay. So if we just talk about these 50 packets, so what do you suggest? Like what happens with these 50 packets? So 25 will be out here, 25 will be out here, or all the packets will be out here?
Yeah.
What do you think? Like what happens in the background? Okay, when we talk about the load balancing, the device will be choosing a single path, either this one or this one. Okay, so let's suppose here we have 10 users. Okay, they are sending 50 packets to a single destination, that is 1.1.1.1.1. So there are chances all the 5 users, the complete data, right, of those 5 users will be via the upper link, and the complete data of the next 5 users will be via this link. Okay. So this so some algorithm here we have in the background, like it will be checking the source IP, it will check the destination IP. On the behalf of that, it will find a interface. So this is like it will put some IDs, ID number 0, ID number 1, right? The link number 0, the link number 1. It will do some algorithm. It will run some algorithm in the background and will choose a single interface to send the complete data of a single user. It means if some user is sending 50 packets, so those 50 packets will be out via this interface or via this interface that will not share these information like 25 packets over here, 25 packets over here. Okay. Clear what is load balancing?
Yeah. Yeah, got it.
This router will perform load sharing, right? So what happens here in that condition? These are 50 packets, right? So what this R router will be doing, it will send 50%. I'll just take a single packet first of all. Let's suppose that user is sending a single ISIM packet, right? And the size of the packet is, let's suppose, 100 bytes. Okay, what it will be doing? The 50 bytes will be out from here, and the 50 bytes will be out from here in the case of load sharing. Okay, it means a single packet even it will do a load sharing. It means the half of the packet will be via this interface and half of the packet will be via this interface. It means if there are 50 packets, so the 50 packets will be via out here, same 50 packets will be via out here, right? But the 50% part only. Okay, same here, the 50% part of those packets will be via this interface or this router. Okay, that is load sharing. So I'm sure like load sharing, load balancing, that concept is clear to both of you, right?
Yeah. Yeah, I don't want to mix up better. So in Ether channel, it do load sharing or still balancing?
That is a load balancing mechanism. Yeah.
Okay.
It clearly says load balancing mechanism.
Okay.
Any doubt in this point?
So can we also achieve load sharing also with the router?
Yeah, per packet, per flow we can do.
Okay.
So once we start the practical side, so just let me know at that time. I'll show you how we can achieve.
Okay.
Guys, any other doubt till this point? Anything?
Yeah, got it.
I'll just take few reference or few examples of the longest prefix match. Okay. Because I'm sure the AD part is clear, the hop count, these things are clear. So I'll just take a look on the longest prefix match. Okay. Let's suppose we have two prefixes, 10.0.0.0 on slash 21. Okay, these two data we have, and we are getting a packet that is 10.0.0.1 to a destination. This is the destination. Okay, from a user, I'm getting a packet, and this is the destination. So at that time, this I'm learning via R1. This I'm learning via R2. So what it will do? Which path it will prefer?
For what is the destination?
Yeah, this is the destination 10.0.0.1. And these are two prefixes that our router is having. One is via R1, one is via R2. There's a router in between that is R3. R3 is maintaining these things. So whenever R3 will get a packet for this destination, so it will choose the best path via R1 or R2.
Via R1.
Via R1.
Yeah.
Okay, cool. If the destination is 10.1.0.1, then
via R2.
Via R2. Sure.
1.0.
This I'm getting via EIGRP. This I'm getting via OSP. And I'm getting a packet of 10.1.0.1. What happens to the background now? which path it will prefer? Via R1 or via R2?
Via R1.
Via R1.
Because of the AD value of EAGRP?
Okay.
No, because first it will check with the longest prefix only. It will goes with that.
Okay.
R2 only.
R2. Okay. So let me just explain you one more thing. Whenever we say longest prefix match, that is basically has two combinations. What two combinations? One is longest.
Subnet.
Yes. Prefix, and one is longest nth, right? So if you talk about length, both are same, the slash value. But if you talk about the longest prefix, this one is having the most prefix matches of the destination, right? 10.1.
Yeah.
So if we say here, these two octets are same here, but in this one, we are just matching a single octet, right? So this one is the most preferred in this case. So in this case, it will not go to the AD value concept, right? It will do a we can say it will take a decision on the behalf of the longest prefix match. Okay, so we have two things. One is longest prefix match, and one is the longest length match, right? Length is same, fine, but the prefix we are matching here. Okay. Good, Simran, this is clear to you now?
Yeah, I got it.
Okay, perfect. If I'll just take one more example. Okay, so here I'm getting a packet 10.9.9. 129. Which path it will prefer?
/26.
Let me add one more. Okay, which one?
/26.
Okay, so you're saying like this path will be the best path.
Yeah, but as per subnetting, .129 is part of the 64/26 network or no? I need to calculate.
Yeah, so what is the final answer?
64/26 start from, I need to calculate first. What is the first IP, last IP?
Okay, so you can just simply like this is 26, it means 2 octets.
Yeah, 26 will be not because.
Sorry? Any answers? Good, Simran. I can't hear you.
I'll go with /25 because 129 is not part of the 64/26.
Okay. So you're saying like the next one is the best, right?
Yeah, because the maximum length is the broadcast of the top. The first one is 127.
And good, Simran, your answer?
I'm thinking about /26.
Okay, /26. Okay, so if we talk about this one, right? So if we just do a subnetting part, right? So that starts from 10.9.9.64 is the network ID. It will end on 10.9.9. Any idea?
127, 126.
127
The
is the
broadcast.
broadcast.
Yeah.
And in between we have the valid IP address, is fine. If we move to the next one, 10.9.9.0, that is 25. It means it will end on 10.9.9. 127 again.
120. Okay, it's the same thing.
So basically, it will choose this path as the best path, right?
Yeah.
So that subnet is 129, and that subnet 129 is not in this subnet, is not in this subnet, right? That is basically the part of this /24 mask, correct?
Correct.
Okay.
Yeah.
Are you sure?
It's easy to choose, but the calculation need to be. Yeah.
Are you sure this one it will be choosing?
Yes, yes.
Why?
I'm still going with
10.0.0.0
/26.
and 0.0.0.255 only. Where we have this one, we do not have this subnet in any of these destination subnet.
Okay. Yeah, it's /24, not 8. Sorry.
Yeah.
8. Yeah.
No
there is no route for that IP.
Okay. So if in this condition, the router will drop the packet for this destination, right?
Correct.
Good, Simran. This is clear to you now.
Yeah, got it.
Okay. So just whenever you see any information, right, in like these things, right? So just process like what is a main subnet, what is a main subnet, and that is under that subnet or not. That's it, right? And
Okay.
if your subnetting part is cool, right? So you can easily answer this part quickly. Definitely. Okay, so I'm sure like this process is clear to you both of them, right? All go till is fine.
Yes.
Lowest AD, we have two different protocols. That time it will see the lowest AD, lowest hop count, metric, cost, depend on the protocol, what we have there, right? And finally, it will be doing the load balancing. Cool. Okay. Now, if we talk about the topologies, we have the unicast communication. We have the multicast. We have the broadcast. And we have the anycast, right? So I'm sure the unicast is clear, that is one-to-one. Multicast is one-to-many. This is one-to-all. What is this one?
One to, that is also one to many, we can say. Usually we use for any cast address for the radius service.
Basically, any cast is basically one to nearest, whatever server we have the nearest, right? So depend on that part, right? It will be sending the packet out to the destination, and we can have the same address everywhere, right? So it will check one to nearest, which one is the nearest to me, right? And it will do a communication to the one to nearest. One to all, as we know, that is a broadcast. Whenever it will send it will try to send a broadcast. So that it means, yes, I'm sending the packet out to all of the users. Many, that's a part of a group. Let's suppose we have 2 groups in the domain, right? So I want to do a broadcast for a single domain, not for all the domains. So that is not a broadcast, that is a multicast. That is kind of broadcast, but not a real broadcast. That's a multicast, right? Because I just want to send the packet out to few of the users, not all of the users, not a single user, few of the users. So that's why that is multicast. And one-to-one, as we know, that is just one-to-one, right? Okay. So guys, any doubt to this point? Anything?
Yeah, like multicast, also like only for the services we use, like OSPF or something. Like we can also do multicast routing, right?
Okay, yeah, multicast routing is a different thing. Whenever you talk about the protocol, they use multicast at this fine, but that is only for the LAN part. If you see OSPF packets, CHR packets, right? So those are remains in the LAN only. They do not cross the boundaries, right?
Okay.
Right. But when we talk about the real multicast, when we have the real servers, some video conferencing servers, at that time they use the multicasting and they cross the routers also at that time, correct?
Yes. Okay.
So that is a part of basically CCIE multicasting, right? So that's a different thing. Okay.
Okay.
I'll share a video to you if you want to learn the multicasting in the deep. So I can share a video to you.
Sure.
Any other questions to this point?
Yeah, got it.
Okay. And you, brother, all good till this point? Okay. So next thing, let me see what we have is Mpls design and these things. Okay. So, so today let's wind up here, right? So tomorrow we'll start with these things. Okay, what is remote site connectivity, MPLS, what is tunnel-based private network? Okay. So here we'll discuss a overview kind of thing, right? Because the details view will be in BGP and MPLS at that time. Once we start doing a discussion of BGP, that time you will see these things, remote-based connectivity, and the GRE also you will see. So we will be having that part here. We'll see that part. Okay, here we are. Okay, so guys, any doubt to this point? Anything?
No.
Okay, so tomorrow we will start with these things, and moreover, we will cover or we'll move to these because again here the MPLS layer 2 VPN, the layer 3 VPN, these are the basically here the overview, right? But the GRE point to point, GRE multi-point, and DM VPN we can cover in the depth. Okay.
Okay.
Okay, so let's wind up. So before the wind up, if you have any doubt, any questions, so you can ask. All good?
Yeah.
Okay, cool. So now just tell me, like for the lab part, what do you use? Like a GNS3 you use or some other software?
I have like both GNS3 and EVNG.
Okay, cool. And Chanakya, you? What do you have?
I have same like I have both
Okay,
like EV.
perfect. And all good, no worries. Right. Okay, so once we start the RIP protocol or the tunnel mechanism and the EIGRP, so at that time we will see the practical side, and on the daily basis I can give you some lab to do, right? And the next day we can like have a discussion on the lab, what like I will share to you, okay? And the doubts we can discuss in the next class. So we'll do like this, right? So the task we have done today, right? So tomorrow, first of all, we'll discuss the doubts first of all, right? And we'll do a discussion on those things if we have something, and then we'll start the new topics. Okay.
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 Okay, guys. Then take care. Bye.
Thank you.
Thank you.
Thank you. Have a good one.